So this video, we're going to look at integrals that require us to complete the square. And so the first place we should really start is how do you complete the square? So I have one video where that's all that I did in it if you are really rusty on this, but I'm just going to do a quick run through and a few examples. And if this is going too fast for you, I recommend that you go back and watch my other video where I go at a slightly slower pace on reviewing this. So I'm going to complete the square on a couple of just polynomials here. And you can't complete the square if you don't have the coefficient of 1 attached to your x squared. So I am going to start by factoring 5 out of my 2x terms, because if I factor the 5 out of this, now I have this in terms of a leading coefficient of 1, and this is what I'm going to complete the square on. Now, this minus 20, I don't feel the need to factor out the 5 because it's really just coming along for the ride, so we're just going to ignore it. Okay, so when you complete the square, you identify the term that is next to your non-squared term, so in this case next to our x. So my b is 2. So you want to pay attention to whether this is positive or negative, so this is positive. And then once you identify your b, you just go through the steps. You take half of that, and then you take half of that squared. This is just what completing the square is. So there's a longer reason as to why all of this is true, but that is not the scope of this. We just need to talk about how do you complete the square. This is how you complete the square. And after you get that number that is squared, this one right here, so I'll make it a little bit more obvious. So this one I'm now going to add into the part where I'm completing the square. So what I mean is I am going to add in the 1 here. Okay, now this is where we have to check ourselves, because I can't just go and add a random 1 to this, right? We can't just go and do whatever we want to an equation or an expression, because then it changes the entire problem. So we have to keep this expression the same. And so now I have to think about how do I reverse the action of adding in this 1. And so what I'm going to do is I have to notice that this one is ultimately going to bounce off of this 5, right? So ultimately I have 1 times 5 that I've added into this, and so now I need to back that out. So since I've added in really 5, I'm going to subtract 5 out here. That's what I'm going to do. And so now I'm going to have 5 times, and I can write this out as 5 times x plus 1 squared minus 25. So the whole point of completing the square is to get a number here so that you can ultimately factor this set of terms. And by the way, this number here, this is always whatever your half b is. So I am always a big advocate of you writing out all of this information, because this is also a map for yourself on what to do next. When people do this in their heads, they usually miss something. I'm just saying. Okay, so let's do another one. Okay, so I recommend that maybe you pause the video here and you try this one on your own and then hit play when you think you've got it, just to check that you are understanding this. So once again, so I need to have a positive x here, and I'm just completing the square on these two terms. So this 4 is just kind of coming along for the ride, so I'm going to leave it out there. So I can go through my same motions again. So my b is 2, my half b is 1, and my half b squared is also 1. So just to make it abundantly clear, this is the number that I am adding in. So this plus 1. And now I need to figure out how do I reverse this thing that I've put into the problem. And so you have to be a little careful with the nuance here, because in this case, this one is bouncing off of a negative 1. So effectively, I have put a negative 1 into the problem when you take what's being distributed here into account. So since I put a negative 1 into the problem, to reverse that, I need to add a positive 1 out here. You need to be able to convince yourself of this. So like pause, and if you don't believe me, like force yourself to distribute this to see that I've just subtracted 1 and added 1, because you have to keep the balance of this, and you have to respect that there's a number in front of here, namely negative 1. So now that I have that, this becomes negative x plus 1 squared plus 5, and a lot of times we write that as 5 minus x plus 1 squared. That's a common way we might rewrite that. Okay, and I have one more here just to make us maybe a little bit more uncomfortable. So I'm going to complete the square again. I do want to just talk about real quick, what do you do if you maybe have like something weird happen with this? So in this case, my b is 3. So my half b, so unfortunately this time I don't have an even number. So my half b is going to be 3 over 2. And I'm just going to roll with this, okay? So when I square this, I'm not going to make this into a decimal. Just run with it as a fraction, because it's actually going to be, it'll like sort itself out. It usually sorts itself out. And it's also easier to square because I just square the top and the bottom. A lot of times people get a little confused about squaring decimals. It's just, I don't know, it's like easier to square a 3 and a 2, I guess. So anyways, so I'm going to go through the same actions. I've got this x squared plus 3x, and then plus this 9 over 4, and then this minus 7, and then this minus 9 over 4. So I've kept everything in balance. So if I wanted to run with this, so remember, I keep saying this, it's that if you aren't sure how this factors, it's always whatever the 1/2 b is. So that's the beauty of having the map here, is that if you get a little lost and you're trying to factor, oh, it's just this, I don't have to think about it. So this is going to be x plus 3 over 2 squared. And now the only other thing that maybe I want to do here is I want to get a common denominator, so I'll multiply this 7 by 4 over 4. So this becomes minus 28 over 4 minus 9 over 4. And so ultimately I get x plus 3 over 2 squared, and then let's see, what is that? That's going to be minus 37 over 4. And, well, you know, it gets the job done. Okay, so we've reviewed our completing the square. So now let's actually do it within the confines of a problem. So in this first problem, so you don't use the completing the square with everything. There's a lot of times where you wouldn't use it, but it's like just another one of those tools in your toolkit, really. So when I look at this integral here, so the problem is that, like, look at what's in the denominator, 2x plus x squared. There's not like a creative substitution necessarily that I can make here that's going to make this any easier. So I need to like think of another way to maybe go about this, and completing the square is a good way to maybe deal with this. So if I complete the square on these two terms here, it's the same kind of set of actions, right? Now, if you wanted to, and this is probably what I would do, I would probably just rewrite this for a second in a way that my brain can like more easily process completing the square. And so my b is 2, my half b is 1, and my half b squared is 1. So I'm just going to kind of do my magic over here on the side, and then I'll deal with the integral in a second. So I'm going to have x squared plus 2x plus 1 minus 1. And so then I can rewrite this as, let's see, as x plus 1 squared minus 1. Okay, so this may or may not do something. So sometimes when you complete the square, it's not going to help, but in this case, we're going to hope it does. So I'm going to have dx over the square root of x squared plus 1 squared minus 1. Okay, so now that we're here, well, oops, and I have a little error here, sorry. This should have been x plus 1 squared. Okay, so now that we're here, so now I can kind of rethink this. The good news is that if I set my u equal to x plus 1, my du is just going to be dx. So this whole thing then can be rewritten as the square root of u squared minus 1. And so the good news is that that actually has a nice little integration formula. So namely, that's going to be the integral of inverse cosh of u plus c. And I'm running out of space here, so I'm just going to go ahead and replace that u with x plus 1 plus c. So that did actually make it something that we could realistically integrate. So that's how you would approach that. Now, let's take a look at another one. So I've got 5 minus 4x minus x squared. Okay, so here's kind of another case, I guess, where like, what else are you really going to do? Because if you think about this, this thing really can't be factored. Now you might, well, it can't be factored in a meaningful way, I guess is what I'm trying to say. So if I were to play around with this, which I think is probably where I would start, so you might try to factor out the negative, and then you might be like, oh, well, it factors as x plus 5, x minus 1. I mean, okay, it factors like that, and sometimes that's helpful, but in the context of this problem, that is not helpful for us, right? Because I can't really do like a substitution with this or anything. So I'm kind of out of ideas. So like a lot of times when you're completing the square, you're just hoping that if you complete the square, maybe it will turn into something that you can actually usefully work with. So what I'm going to recommend, you complete the square and you come up with an idea of how to integrate this, because remember, math is not a spectator sport. Be way better if you tried this and struggled with it versus just watching me, who really knows this stuff, explain it to you, because I already know it. So try it, hit play when you're ready. Okay, so I am going to factor out the negative on just the x terms, and I'm going to just roll with this 5. And so let's see. So I'm going to have that my b is 4, my half b is 2, my half b squared is 2. So I need to just be careful with this. So I'm going to add in 4. And then I want to pause for a second because I want to make sure I'm maintaining the balance here. So this 4 is ultimately being bounced off of the negative. So I've got really a negative 4 here. So I need to just kind of counteract that by adding 4 out here. And so this is going to give me negative x plus 2 squared plus 9, which I could rewrite as 9 minus x plus 2 squared. Okay, cool. So let's just rewrite the whole integral as 9 minus x plus 2 squared. And in this case, I could use a trig substitution. It's kind of your classic trig substitution form now. Now, if you wanted to, you could do the same trick where you say, oh, my u is x plus 2, and then your du is just going to be dx. I personally feel that in the context of this particular problem, if I make this substitution, it doesn't turn into an integral that I can magically integrate, if that makes sense. So I personally am going to skip this, but if this is what makes sense in your brain so that you can see the trig substitution, then do it. So you also got to kind of at the end of the day, like do this in a way that makes sense for your brain. Okay, so let's make some space. Okay, so now we can move forward with doing a trig substitution. So this is in the form where the thing that's being squared, so instead of it being just x squared, it's all of x plus 2 squared. So that is going to equal 3 sine theta. And so then I'm going to take the derivative of each side. So this becomes dx equals 3 cosine theta d theta. Okay, and so now we're just going to make our happy little substitution. And then replace my dx with times 3 cosine theta d theta. So I'm going to have that this is going to be 9. I'll just factor the 9 out. So this becomes 1 minus sine squared theta. And then this is times 3 cosine theta d theta. Let's see, I'll make some space. So ultimately we get 9 cosine squared theta times 3 cosine theta d theta. So I'm going to have 3 cosine theta times 3 cosine theta d theta. So now I have this 9 times cosine squared theta d theta. So this is one of your classic basic integrals. So I can rewrite this as, what is it? It's 1/2 plus, this one's plus, yeah, plus cosine 2x over 2, oh, sorry, I wrote x, I meant theta, 2 theta. Okay, so there's what I need to integrate. So let's see, I'll just pull the 9, the 1/2, so I'll just write this 9 over 2. So I get theta plus 1 over 2 sine 2 theta, so all of that plus c. Okay, now this is a trig substitution, so we really got to make some space and now analyze all this. So here's where I'm at, and recall, so the whole thing that kicked this off was that x plus 2 equals 3 sine theta. So what that means then is that sine theta is equal to x plus 2 over 3. So I can make my reference triangle now based off of all this. So here's like my theta. So my hypotenuse will be 3, and then the opposite side will be x plus 2. And so then when all is said and done, this side will end up being 9 minus x plus 2 squared. Okay. All right, so now I can start working on filling this in. Now, this right here, this is a classic trig substitution trick in that you need to know that sine 2 theta is equal to 2 sine theta cosine theta. This particular identity gets used a lot with trig sub, so it is something that you should really know. Okay. I'm going to really fill in here then 9 over 2 theta plus, so this 1/2 times this 2 are just going to cancel each other out. So this is going to be just sine theta cosine theta, and then of course all of that plus c. Okay, so now let's go through and finish this. So to solve for my theta, well, here was kind of my original setup here. So to solve for theta, I just take the inverse sine of all of this. So this is going to turn into inverse sine of x plus 2 over 3. Okay. And then for my sine theta, so we already know what sine theta is. So that's x plus 2 over 3. And then for my cosine of theta, so that's going to be my adjacent over my hypotenuse. So that's going to be the square root of 9 minus x plus 2 squared over 3. And then I've got this plus c kind of crammed in there, of course. Okay, so now if I try to simplify all of this, so this is going to turn into 9 over 2 inverse sine of x plus 2 over 3. And then when I multiply this 9 over 2 times this over here, so just notice that these 3's will end up canceling out with the 9. So I'm left with x plus 2 times the square root of 9 minus x plus 2 squared, all of this over 2 plus c. Whew, all right, that was a good one. Love that. Okay, so you've seen kind of two different ways that I guess the completing the square can manifest itself. So hopefully that's helpful. I have more videos that are like this. If you found this one helpful, I would love it if you hit that like button, subscribe button, or you could leave me a comment about how things are going. But I will leave it at that, and I will catch you guys in another video. Peace.